Last video, I said I'd help train Skynet in 2D top-down combat, so I did. This is Warlord. It is a vibe-coded game based in actual engineering principles with an opinionated stack, and the game itself was done in about an afternoon, about 2 hours. So not the 30-minute fantasy that I may have pitched. But the enemy army is run by a local AI on my own machine. No cloud, no API bill, and not really connected to Skynet. The first version I built, I tried to break the game. It picked moves that don't exist. It froze the server while it sat there thinking. Now, vibe coding got me the game. Engineering got me the enemy that doesn't fall apart. So, here's how I built it. So here's the one idea the whole thing rests on. See, the AI is not choosing pixels or clicking units, it picks play, like a coach calling one in from the sideline. You bunch your gang into a tight clump, and it pincers you. Two claws swing wide to both flanks, and the lobbers hang back and make it rain. And I'm not talking about the fun make it rain that you and your friends might have done at certain clubs of the night. I'm talking about making it rain axes. And they do that so you can't retreat through the middle. Now you hold the line instead, and it won't trade blows with your front. It's going to swing to the open, left or right, and it's going to roll you right up with a flank maneuver. Now the size sets a temperament. A platoon is about 4 to 5 squads, and squad is about 5 to 6 people. So you're looking at about 30 to 35 soldiers that are getting ready to take you head on. You see, if you have a platoon and their platoon can't maneuver around your platoon, can't wrap you up, can't wall you off, it's just going to harass and charge you until you start whittling down your numbers and retreat. Or, they take you over. Skynet is pretty good at doing that. Now, company is a different animal. It forms a wide arc, nearly surrounds you, and it tightens that noose over time. A company, for reference, is about 4 to 5 platoons. So 4 to 5 platoons was 30 to 35 people. So now you have 125 little goons controlled by Skynet, these tiny little terminators, tightening up that noose. So it's the same brain with a bigger body and a lot meaner options. And it wouldn't be Skynet if it didn't watch what you do. So lob an area attack into a bunched up squad, and they will scatter that instant to get out of the blast. It doesn't wait its turn. So how often does it decide? Well, on contact first. Then it commits to play for a few seconds so it isn't twitching every frame. I mean, Skynet, they got to be some sort of smart when they send their terminators in. But it'll reread you the instant you change tactics. So you switch your formation mid-fight, you can watch the counter change. Here's the decision start to finish. Read the battlefield, score every play in the set, pick one, validate it, execute. Sitting above that is a strategic loop, deciding when to commission more troops and when to peel off a platoon to flank you while you're pinned. Because Skynet does not play fair. This is man versus machine. A model proposes, a deterministic rule decides, and that's the same pattern I built into everything. Now when you clump, or you put your little anti-terminators and the resistance into files and ranks, it doesn't reach for something clever. It's a machine. It scores all 14 plays for the exact read. Pincer scores the highest, so Pincer wins. The cause is right there on the screen. You clumped, it pincered. So, Where does the language model actually sit? Well, it doesn't drive, it proposes. It hands back one pick from the list. That pick is validated and it's off the list or too slow. See, a plain procedural picker takes the wheel when the model can't decide. The model gets asked nicely and it's never trusted. Just like Sarah Connor couldn't trust old Arnold. So that's the idea. Now here's the code that holds the leash. If you don't care about the internals, go ahead and skip ahead. If you do, this part is the whole trick. So start here. There's 14 maneuvers written down as one closed set, and this is the entire menu. The model can only choose one of these. It cannot invent a move because there's no slot to invent one in. When it picks, it returns an index to that list, not free text, so the Terminator is not susceptible to prompt injection. It simply scores the set, squares the weights so the best counter clearly wins, and returns one entry. There is no path where it makes something up. The read drives the weights. You clump, pincer gets a big bump. You hold the line, the flank gets it. Lob comes in, those little Terminators are going to scatter into spikes. It's a handful of honest biases over a small read, and every number is yours to tune. Now, the model lives behind a gateway on the server. The browser never holds it. Now, I know some of you are probably saying, duh, that model is 18 gigabytes. How would you fit that into Google Chrome? Well, you don't. You put it on a server. Every call gets a hard timeout because a game loop can't sit and wait while the model thinks. So you get a slow answer, we just cut it off. This is the part that matters. The reply gets validated against that same closed list. Valid, the model's pick overrides the baseline. Off list or timed out, we keep a procedural pick and we just counted a miss. And I measured the miss rate. The share of times the models went off list live on the HUD. That number is the on a ceiling. It's exactly how often we let the AI drive and how often would it have done something dumb, cut, and get dropped before we ever touch the game. So running it is two commands. Start the local model, start the server. When the gateway answers, the AI picker switches on. If the model isn't there, it falls back to procedural and the game still plays fine. Now, I didn't vibe my way past the tests. You have 8 files and 63 of them are green. So the maneuvers, the pickers, the combat math, the fun part moved fast, but the correctness part still got checked. So that's the whole thing, end to end. Your machine, your model, your meter. No frontier models in this bad boy. If the model proposes and a deterministic rule decides. That's the line between a demo and something you would actually ship. So, if you want to build something like this with me, I do offer a free school, which is down below in the description. You're welcome to check out the free courses there and download the companions, the Vibe Code Game Companion, and Warlord itself are publicly available on the GitHub links in the description. And also, we have a Discord, so that way you can meet other like-minded individuals that are interested in building cool things based in solid engineering principles. So you're welcome in advanced Skynet. Let's build.